The next type of problem we want to look at is what happens when there is a common ion. This is a theme that we have found in the previous few chapters. What would be the solubility of a salt if there's already present an ion that is also present in the equilibrium? For example, let's say I have a solution of silver 1 carbonate. This is an insoluble salt, which means it's slightly soluble, which means in water. We will have this equilibrium. This equilibrium has a KSP value that I can look up in a table. The table in our textbook lists this as 8.5 times 10 to the minus 12. It's a very small value for the equilibrium constant because this is an insoluble salt, which means it's only slightly soluble. If I want to know what is the solubility of this salt, the molar solubility, I would solve for it as we saw in the previous video. I would solve for X. Alright, so the molar solubility would be 1.3 times 10 to the minus 4 molarity. I could calculate the silver ion concentration, that would be 2x, or the carbonate concentration, that would be X. Please note that the math on this side will look different depending on the stoichiometry. If there's 3 of one ion, I'm going to have a 3x cubed somewhere. So be careful with that. Be careful with that. Pay attention to your stoichiometry. You cannot simply memorize this part of the equation. It's different for different equilibrium reactions. So that would be the solubility in pure water. By that we mean all I have in my aqueous solution is the silver 1 carbonate. Let's say I have a common ion present. In other words, I've got a solution where there's already some silver ion. For example, let's say that I have some silver 1 acetate. Silver 1 acetate is soluble. All acetate ions are going to be soluble. And let's say I have a solution with a 0.05 molarity concentration of silver 1 acetate. That means my silver plus 1 ion concentration is also 0.05 molarity in this aqueous solution. My acetate ion is also that, but it doesn't really matter because acetate ion does not show up in my equilibrium reaction. Only the silver plus 1 ion does. So what would be the solubility of my silver 1 carbonate in a solution that already contains some silver ion? I could calculate it again using my ice table. Now here, my initial silver plus 1 concentration is not 0. It's 0.05 molarity. It is not 2 times that. I have a certain amount of silver plus 1 ion concentration at the beginning because of the silver acetate. It's 0.05. My carbonate is still 0. If I finish filling out my ice table, I end up with this. Now the math looks like this. Now my 8.5 times 10 to the minus 12 is equal to the concentration of the silver plus 1 ion squared. Here's my silver plus 1 ion concentration at equilibrium times the carbonate ion concentration. At equilibrium it's X. And now I have a quadratic equation, which is going to, actually it's a cubic equation, isn't it? Once I square this, then I'm going to have to multiply by another x. The algebra here is a little messy. Typically in this case, we can assume an approximation. Since the KSP, the solubility product constant for this equilibrium reaction, is so small, there is a very small amount of silver plus 1 and carbonate minus 2 ion that are being produced, which means my X, the molar solubility, is really small. The molar solubility in pure water was 1.3 times 10 to the minus 4. What we're going to see in this case is X is even smaller if I start with a common ion. So my X value is going to be even smaller than 1.3 times 10 to the minus 4, which means by the time I add even 2x to 0.05, I essentially have 0.05. I can make an assumption that 0.05 plus 2x is approximately equal to 0.05. If I have $1 million and you each give me $2, I'm still going to have $1 million. That means our math simplifies a little bit, and now x is very easy to solve for. Notice that x is now smaller because a smaller amount of my solid will actually dissolve or dissociate because I have a common ion beginning in my solution. So my molar solubility in a solution that already contains this much silver plus 1 ion is only 3.4 times 10 to the minus 9 molarity. Compare that to the molar solubility in pure water. The molar solubility has gone down. In terms of Le Chatelier's principle, if I already have a product in my equilibrium reaction, or I add some silver plus 1 ion to this equilibrium system, it will shift to the left, which means that my silver 1 carbonate will be less soluble because of Le Chatelier's principle, because I do have the common ion. So you might need to figure out a molar solubility with a common ion present, or you might need to figure out what an equilibrium concentration would be with the common ion.